Kashish Vazirani, and today I am going to explain homework 5, question 1. So, this is our question. If x and y are independent, with f of x equal to u of x minus 1 minus u of x minus 2, and f of y equal to u of y minus u of y minus 1, and z is equal to x plus y, find f of z. So the first question says find it by a convolution method. We know that x and y are independent. That's why we know that f of z can be found by convolution method. Had these not been independent, convolution method would not be possible. So in this case, we are shifting f of y. So there are four basic functions that one has to perform in convolution, and the four functions are these. First, you have to write x and y on alpha axis, then you flip one of them, and in this case we are flipping f of y, and then you just add z to the flop function, and then you slide. So slide, basically, of course, you can do it by the method of using figures, or you could find the limits like I have found in my case. But if you were to draw, you would draw f of x and f of y in this way. So this is step 1, a general unit function. This is a unit function shifted by 1, and this is a unit function shifted by 2. If you were to draw f of x, which is unit function shifted by 1 minus unit function shifted by 2, you would do this minus this, and that's why you would get a unit step function going from 1 to 2. And if you were to draw f of y, which is unit function minus a unit function shifted by 1, so that would be unit function minus unit function shifted by 1, you would get something like this, because it is 1 minus 0 from 0 to 1, and then from 1 onwards it's 1 minus 1. So that's why the rest of it would be 0, and the same goes in this case. It is, so we're doing this minus this. So from 0 to 1, it's 0 minus 0, so you get nothing. From 1 to 2, it is 1 minus 0, 1 minus 0. That's why you get it from 1 to 2. And then from 2 onwards, it's 1 minus 1. So you just get this one block here. So if you were to draw this on the alpha axis, the only thing that would happen is that this would become the alpha axis, and this would be f of alpha, and this would become the alpha axis, and this would be f of alpha. And if you had to add z to the flopped function, so first you would have to flop this. So this would just get shifted like this, and then you would just add a z to it. And then if we were to do it diagrammatically, this shifted block would keep moving towards f of x of alpha until they reach each other. So something like this. You would go on plotting something like this and find the limits and therefore find the answer. But if you had to do this in another way, without using diagrams, if diagrams get confusing, this is what you would do. So by the convolution method, first we know fz of z is fx of z convolved with fy of z, which can be written as fx of alpha, fy of z minus alpha d alpha. This is given to us in the question. We could have even shifted the f of x by z, but we shifted f of y, so this must be kept in mind. Whatever is given in the question should be solved. And then so everywhere this is f of z. Okay, so and then you have to open up the brackets, so you get u of alpha minus 1 into u of z minus alpha, going from minus infinity to infinity. u of alpha minus 1 into minus u of z minus alpha minus 1, going from minus infinity to infinity. And similarly, you multiply u of alpha minus 2 into these two functions. So this is what you'll get. Now you have to find the limit of each of these integrands. So what we do is we use a general formula to determine the limits when a step function is involved. So if you had this u of x minus beta, u of x minus alpha minus b, u of alpha minus b, and you had another function going in the minus alpha direction, say it's u of t minus a minus alpha, the upper limit would be t minus a and the lower limit would be b, not minus b but b. So lower limit would be b and upper limit would be t minus a. So this is a basic general formula to find the limits when two step functions are involved. To find the limit when two step functions are involved. Okay, so where were we? All right, so if we had to find the limit of this particular function out here, you know this is alpha minus 1 and this is z minus alpha. So this is like alpha minus b and z minus alpha. So in our case, b is 1, that's why our lower limit is 1, and z minus alpha is equal to t minus a minus alpha. So z is equal to t minus a and upper limit is z. Similarly, the second one, the lower limit would be 1 and upper limit would be z minus 1. The lower limit would be 2, upper limit would be z. Lower limit 2, upper limit z minus 1. So, alright. And what you're going to be left with inside is basically, so this is a unit step function, its integrand is 1. So 1d alpha into u of z, 1d alpha into u of z minus 1, 1d alpha into u of z. So you know that the shifted, even if the unit step function is shifted, if you're going to integrate it, it's still going to be 1. Its magnitude is always going to be 1 wherever it exists. So you already know where it exists. That's why its magnitude is 1. So anyway, so this is what you get finally after using this formula. And then you simply open up the brackets. So upper limit minus lower limit into u of z, upper limit minus lower limit into u of z minus 1, upper limit minus lower limit into u of z, upper limit minus lower limit into u of z minus 1. And then once you open it up and you take u of z common and u of z minus 1 common, u of z common, you're left with z minus 1 minus z minus 2, u of z minus 1 common, you're left with z minus 3 minus z plus 2, and then this is what you get by the end of it. And this is your final answer using the convolution method. If you were to use the geometric method, you would it would be easier to draw a figure first. So x-axis, y-axis, we know x looks something, f of x looks something like this and f of y looks something like this. So basically it's 1 between 1 and 2 and 0 otherwise, and it's 1 between 0 and 1 and 0 otherwise. So if you were to plot it here, you would realize that they kind of have a common area here. So basically f of z would exist just in this small block, and then you would have to take the lower limit and the upper limit and solve the question accordingly using using basically the f of z function. So f of x y, x comma y, dx dy, and then you would have to find the appropriate limits for x and y. So that is the method of doing it using the geometric method. Thank you.